We'll be looking at the sum, the difference, the product and the quotient of functions in this lesson. So let's start off with an example. We're asked here to consider the functions fx is equal to x squared and gx is equal to x plus 1. Now we're asked to find firstly the sum of these two functions, so fx plus gx. Now we'll do each of these functions separately, so our fx to begin with, that's just equal to x squared, we'll write that down. Then we're going to add to that our second function, or our gx. Now that's x plus 1. Now once we've got that result, important to look at the answer here and just check to make sure there's no like terms that can be added together. In this case there's none, so our final answer, x squared plus x plus 1. Now let's have a look at part B, fx times gx. So this time we're looking at the product of the two functions. So the same process, we'll start off with our fx, write down our x squared there. Now we're going to multiply that by gx. So there's our x plus 1. We'll actually put that in brackets. That's generally the way we multiply two functions together. Now we can expand that out, so we'll get our x squared. First of all, we're going to multiply it by our x, so that gives us x cubed. We then multiply it by the plus 1 here, so that's x squared. Now, just like before, have a quick look at that. Make sure there's no like terms, none here. So once again, we've got our final answer, x cubed plus x squared. Now let's have a look at part C, this time looking at the quotient of the function, so fx over or divided by gx. So our fx to begin with, that's x squared. That'll be over our gx, so over x plus 1. Now once again, we'll just have a look at that result. Make sure there's nothing that can be factorised and then cancelled down. Well, nothing can happen there, so our final result for the quotient is x squared over x plus 1. Excellent. Well, now we're going to consider the domain of functions. So if we're given the two functions, fx and gx, well, if we want to find the domain of fx plus or minus gx, so the sum and the difference of the two functions, to calculate that domain, we look for this result here, df, or the domain of fx, intersecting with dg, or the domain of gx. Now you may have noticed that funny n there. I use the word intersects, and that's where those two domains intersect or overlap. Now if we're looking the product of the two functions, so fx times gx, to find the domain, we use exactly the same result, where our domain of fx intersects with the domain of gx. Now lastly, for the quotient, fx over gx, well, once again, to get our domain, we use the same result. There's one special condition here though. Because gx is on the bottom of a fraction, we know we can't divide by 0, so that means we have this condition here, where gx can't equal 0. Just need to be careful with that one. Alright, let's just put a box around them, just so they stand out for us, and we'll use them to help us out with our second set of examples here. So we're given fx is equal to the square root of 5 plus x, and gx is equal to the square root of 3 minus x. Now firstly we're asked to find the domain of fx plus gx. So we're looking at the sum of our functions here. Well, let's just write out that function first of all, our fx plus gx. So fx there is our square root of 5 plus x, and then we're going to add to that our second function gx, which is that square root of 3 minus x. Now we need to find the domain of that function. Well, it's pretty tricky to do it in one go, so we're going to use the result from up above. First of all, we'll find the domain of fx. So if we have a look at that, it's under a square root. Now we know we can't find the square root of negative numbers, so that means that 5 plus x must be greater than or equal to 0. Now we'll just rearrange that though, just to make sure that x is the subject there. So we'll take 5 away from each side, giving us x is greater than or equal to minus 5. Now that's our domain there written as an inequality. We can also write that using interval notation, saying that x ranges from negative 5 to infinity. Just noting we've got that square bracket with a negative 5 there, to show that that's an included value for the domain. Now let's have a look at our domain of gx. So there's our function, once again under a square root. So we know that 3 minus x must be greater than or equal to 0. Now this time we've got a negative x. To make x the subject, we're going to add x to both sides of the equation here, giving us 3 is greater than or equal to x. Now we usually have the x on the left-hand side, so how about we just reverse that inequality, giving us x is less than or equal to 3. So once again, there's our domain as an inequality. We'll just rewrite that using interval notation though. and x ranges from negative infinity to 3, with that square bracket beside the 3 there. Once again, just to show that that is an included value. Now let's draw ourselves up a number line, and we're going to put each of those domains on there, starting off with x is greater than or equal to negative 5. So we have a closed circle at negative 5. Now x is greater than or equal to that, so that's all the values to the right there. And next one, x is less than or equal to 3, closed circle at 3. Well, for less than or equal to, all the values to the left. Now to calculate our domain, having a look up the top here, we're looking at where those two domains intersect or overlap. So that's this region on our number line here. Now that's all the values between negative 5 and 3. Now x is between them, so put the x there. And the way that we would write that out is negative 5 is less than or equal to x, which is less than or equal to 3. Excellent. Well, that's our domain as an inequality. Let's just rewrite it using interval notation. So our x values go from negative 5 to 3. This time square brackets on both ends, as both of those values are included in the domain. Fantastic. Let's have a look at part B now. Find the domain of fx over gx. So this time we're looking at our quotient. Let's just write that out first of all. We've got the square root of 5 plus x over the square root of 3 minus x. Now if we look up the top here, we can see that the domain is the domain of fx intersecting with the domain of g. But we've got that special condition there, gx can't equal 0. So in actual fact, that's the same domain as a with that one extra condition. This denominator here can't equal 0. Now we can effectively ignore the square root there and just say that 3 minus x can't equal 0. Now we'll just do a bit of rearranging of this here. We're going to add x to both sides of the equation, giving us x can't equal 3. So let's finish this off. The same domain as a, so that's that one there. Negative 5 is less than or equal to x, which is less than or equal to 3. But we've got that condition there. X can't equal 3. So have a look at that end there. Got to get rid of that equal sign, giving us a final result. Negative 5 is less than or equal to x, which is less than 3. Now let's do that one using interval notation at all. So our x values range from negative 5 to 3. This time though, note, we've got the square bracket for the negative 5, as that value is included, but the curved bracket for the 3, as it's not included in the domain. Fantastic. Let's have a look at another example now. You're given fx is equal to 2 plus 3x, and gx is equal to x squared. Now in part A we're asked to find the domain of fx times gx. So let's work out this product. There's our fx, there's our gx. Let's multiply them together. Now if we have a look at that, that's actually quite an easy one to expand out. So we might do that, and it gives us 3x cubed plus 2x squared. Now let's just have a look at that product there. No square roots, no denominators. So with our domain, there'd actually be no restrictions on our x values. And the way we write that is so that the domain is all real x. Or if we're to write that using interval notation, our x values go from negative infinity to positive infinity. Now for part B, we're finding the domain of fx over gx. So let's just write out the quotient. There's our fx, there's our gx, write them as a fraction. Now we're finding the domain of the quotient, so remember, special condition with our denominator there. We know that x squared can't equal 0. Now if we take the square root of both sides there, we end up with the condition x can't equal 0. Now to write out the domain of our quotient here, well, we know it's the same result as in part A, so all real x, but we've got this condition here that we need to note. X can't equal 0. Now another way of writing this domain is to say that x is an element of the real numbers excluding the value 0. So the capital R shows it's part of the real numbers, then that backslash 0 in parentheses shows that that value is excluded. Excellent. Let's have a look at part C now. Slightly different this one. We're finding the range of fx plus gx. So we'll start off working out that sum. There's our fx, there's our gx. Add them together, giving us x squared plus 3x plus 2. Now have a look at that there. That's a quadratic. When we work with quadratics, we often factorise them. Now if you've forgotten how to do that, there is a separate lesson on that, but that'll factorise to give us x plus 2 in brackets times by x plus 1. Now remember, we're finding the range of this sum here. And the quickest way to find the range is to draw a quick sketch of the function. We'll use this factorised version down here. So draw ourselves up our number plane. Now we know that the x-intercepts will be -2 and -1, taken from each of those brackets there. Now it'll be a concave up parabola, positive x squared, so we'll just draw ourselves a rough sketch there. Now this vertex or minimum value down here, that's really important when it comes to calculating our range. That'll be halfway between those two x-intercepts. So our vertex will have an x value of -1.5. Now if we take that x value, sub it into our sum up here, y is equal to -0.25. Now let's just put those 2 points down on the diagram there. And that y value there, we're just going to put that over here on our y-axis. Now to calculate our range, we can see from the graph that our range is all of those y values there, from -0.25 up. So that means that y is greater than or equal to -0.25. Now, just like we've done with our domains, that's our range written as an inequality. Let's just write it out using interval notation. So our y values go from -0.25 to infinity, with that square bracket on our -0.25. Once again, it's an included value. Fantastic, big lesson there. Well done working your way through all of that. Now good luck as you work your way through your questions.